Says at time t greater than 0, a particle moving along a curve in the xy plane has position x of t, y of t, with velocity vector v of t equals cosine of t squared and e of 0.5 t. And at t equals 1, the particle is at the point 3,5. A wants us to find the x-coordinate of the particle at t equals 2. So if I want to know the x-coordinate of the particle at t equals 2, I'm going to be using this information here, the x-coordinate when t equals 1, and I'm also going to be using this derivative information because this is really x prime of t. So I know that my position at time 2 has got to be equal to the position at time 1 plus the integral from 1 to 2 of my function, which is b cosine of t squared dt. So I'm going to jump over to my calculator real quick, and we're going to go to our home screen. And I want to figure out what x of 1 is, which is 3, plus the integral. And I'm going to be integrating cosine of t squared with respect to t from 1 to 2. And we're going to find out that x of 2 ends up being 2.557. And again, in this problem, I don't need units because there are no units here. So I don't need to worry about units in any of my question. I don't need to worry about hours or seconds or meters or feet or anything like that. So this is my horizontal position at time t equals 2. For 0 less than t less than 1, there's a point in the curve at which the line tangent to the curve has a slope of 2, and at what time is that object at the point? So for us, we know that the slope is supposed to be the change in y over the change in x. But because we're parametric, I'm really looking at y prime of t over x prime of t. So I want to know when e to the 0.5 t over cosine of t squared is equal to 2. And so I want to look at when this is going to be true. And again, graphing is probably going to give us our best representation here. So I'm going to jump over to my graph. I'm going to clear this equation out. And I want to do e to the 0.5x, because I'm graphing y as a function of x, divided by the cosine of x squared. And I want to know when this is equal to 2, so I want to graph the line minus 2. And I also want to change my domain because our domain's going from 0 to 1 in this problem. And what will happen is if you actually graph this, you'll see that this oscillates wildly past 1. So if I graph this function, I'm going to see where this actually intersects the x-axis. And it thinks it can, 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 right about there. So again, algebra is our friend. We want to find the 0 of this function somewhere between 0 and 1. And we end up with a solution of 0.840. So t equals 0.840. For part C, they wanted to find the time at which the speed of the particle is 3. So remember that speed is equal to the square root of x prime squared plus y prime squared. So when I'm looking for the speed and I want to know when it's equal to 3, I'm going to be solving the equation where I've got cosine of t squared plus e to the 0.5t squared. So I'm going to go back to the exact same graphing situation just to find that solution. So we're going to type in our equation again. So I'm looking at the square root of stuff, and it's going to be stuff squared plus stuff squared, and now I need to fill in my stuff. This first stuff is going to be cosine of x squared, and I need to close that cosine function. And I'm going to do the exponential, so this is going to be e to the 0.5x. And I like to put in the parentheses first before I start substituting in the values, because then I make sure that everything's balanced. And everything looks really good here. And I want to know when this is equal to 3, so I'm actually going to go back up here, go to the end of this, and subtract 3. Because I want to know when this is going to be happening here. And I don't know if that's going to happen in my domain, so I'm going to expand this out. Notice there's no mention of my domain here. So let's just type in any reasonable value. 5 sounds good. So if I graph this, then here is this is my speed graph. My speed ends up doing this. So this is where my speed ends up being equal to 3, somewhere between 2 and 3. So I'm going to go to my algebra and find the zeros somewhere between 2 and 3. And so I find out that my time is equal to 2.196. So this is the time at which my speed ends up being equal to 3. And then we get to part D, where it wants us to find the total distance traveled by the particle from time t equals 0 to time t equals 1. And I know that the total distance traveled by the particle, that's the arc length. So I want to find the arc length, the square root of, this is going to be x prime squared, so cosine of t squared squared, plus y prime squared, which is going to be e to the 0.5t squared. And I'm going to be integrating that with respect to t. So I'm actually going to jump back to my graph just for a second, because I actually want to copy this. So I'm going to hit enter, and I'm going to copy this expression, and then I'm going to go back to my home screen, and I want to integrate. So I'm going to do integrate, and I'm going to go ahead and paste this in, but I don't want that minus 3. And I want to integrate this with respect to x from 0 to 1. And when I hit enter, calculator thinks for a while. So the thing is, the distance is equal to, on part D, and this is equal to 1.595. Now again, on all of these that we had rounding, I could write 1.594 or 1.595, and they've given points for both of those, so just be aware that that's there. Again, if you always write 4 decimal places, then you should be good, because then you're writing something that is correct and is going to round to the answer that they have. So looking at the points on here, you're probably going to get 1 point for writing this fundamental theorem of calculus form and 1 point for your numerical answer. Here you're probably going to get a point for writing that slope is the ratio of y prime over x prime and 1 point for your answer. You're probably going to get 1 point for your speed equation, 1 point, or your speed function, I should say, 1 point for setting it equal to 3, and 1 point for your answer. And then over here, you're going to have 1 point for your arc length function and 1 point for your numerical answers. So I'm thinking that's where the 9 points